Hello, I'm Piero,
I'm Michael.
and for our final project, we decided to create a pool game simulation.
In our presentation, we're going to go over the four main parts. So, our motivation of the project, some backgrounds to the project, some physics review, literature study, and the approach to how we implemented the project, and lastly, some demonstrations of our results. So, the motivation of our project is to make a pool game with real rigid body physics concepts modeled in 2D. So we used physics that involved friction, wind, and also the applied force between cue sticks and also the balls. We handle collisions between the ball and the table, the ball and different balls, and also between the ball and the holes. In our UI and visual aspects, we implemented integration that visual fixes to our integration. We handled textures on the balls and the tables. We implemented motion blur and also added all the gameplay mechanics that make a pool game work.
And so for a little bit of background, some of the forces that we talked about was like wind. So as the ball moves at really high velocities, it's going to be crashing against the wind, slowing it down. Of course, there's also friction with the table. So that's also going to be slowing it down in the opposite direction that it's moving in. And then we also had to learn to how to add applied forces. Obviously, when the cue stick strikes the ball, it's going to have this applied force on it initially, and how it like interacts with other balls. And that leads into collision handling. For this, there were two main algorithms that we were looking at. One was simultaneous collision handling. And then what happens here is that on a collision, each ball gets updated, but then it's not displayed until like all of the balls new positions have been updated. So you get like this sort of weird sliding motion. And then the other one was the serial collision handling, where it's the ball gets on a collision, the ball's position gets updated, but then like in that moment, so then in the next collisions, the new positions are taken into account. And so if you've ever played pool before, this is more of what's likely to happen when you see a ball strike two balls that are next to each other than the first one. As far as integration, we sort of just took a lot of concepts from homework 3, like separating this pool system from the time stepper and integration methods. So for the approach for the serial collision handling, this is a little bit of the pseudocode. So for each ball in our balls array, it would also check collision for every single other ball that it still has left to check a collision with. And then it updates its position if there is a collision as the for loops run. So that this way the effects of the collisions are propagated correctly for other ball collision checking. And then for the collision algorithms, so here's a very simple one with just like the ball with the table. So in expectation, we'll see that the ball has one collision detected once it intersects with this wall here, and then the new direction will be calculated. But in reality, what happens is that this old direction will get flipped, right? But then in the next iteration, because the ball is still sort of overlaid against the table, over the table, it's going to detect that as another collision. And so then it's going to alternate between these two states essentially forever. And so the ball will never like actually move. It'll just stay right there. And so to fix this, we simply clamped the position once we found a collision, so that on the next iteration, it would not consider it a collision, and then it would move as expected. A similar thing was done for collisions with balls on other balls.
So here are some demos of our results. First, we can see our ball and table collisions. Our clamping can be seen here as the balls look like they're very smoothly bouncing off the table edges. Next, we have the ball and ball collisions. As you can see, this is the starting position of our pool game. And as the cue ball hits the triangle, all the balls are moved by like the propagation of forces from the cue stick. And here is our full gameplay, which we won't be able to show entirely in this presentation, but feel free to take a look at it when you have time.
But yeah, thank you so much for watching. Appreciate it.
Yep, thank you.
Mm.